Today I'll be providing a solution to one of the integrals from the 2006 MIT integration bee. First off, let's notice that this denominator has terms that are degree 4 and 1 respectively. And on the numerator we have a term of degree 3 and degree 0. When you have a denominator that is 1 degree higher than your numerator, it's usually a good sign to do a u substitution. So I'm going to let u equal x to the 4th power plus x. So I switch these two terms around. Then du is equal to 4x to the 3rd power plus 1 dx. However, there is a small problem. This numerator does not cancel with our du here, so we're going to have to do something about that. What I'm going to do is to split this integral into two different integrals. First off, I'm going to have 2x to the 3rd power plus 1/2 over x plus x to the 4th power dx. And then I'm going to add the integral of negative 3/2 over x plus x to the 4th power dx. Now if you just check, 1/2 minus 3/2 gives negative 1, so we are allowed to do this. Now let's focus on this integral. So I'm going to paste this down here. Okay, so I'm going to multiply this by 1, but not just any 1. I'm going to multiply by 2 and then divide by 2. So first off, I'm going to have a 1/2 outside of this integral. And then I'm going to multiply the inside by 2. And in fact, I'm doing this because you'll notice that if we multiply this numerator by 2, then we just get our du. So this is a good sign that things will cancel out. So now we have 1/2 times the integral of 4x to the 3rd power plus 1 over x to the 4th power plus x. We just switch these x terms around. And then dx. Now if we let u equal x to the 4th power plus x, we see that what we have here in the numerator is just du. So let's write that down. This is just 1/2 times the integral of 1 over u du. So this was du, this was u. And this is simply 1/2 times the natural log of absolute value of u. And I'm going to add a constant plus c1 for now. But now remember, u equals x to the 4th power plus x. So this is equal to 1/2 times natural log of absolute value of x to the 4th power plus x plus c1. So this is the first part of our answer. But now we still have to evaluate this integral. So I have copied this integral over here. First off, let's bring this constant multiple of negative 3/2 outside. So we get negative 3/2 times the integral of 1 over x plus x to the 4th power dx. Now you could try to factor out an x in the denominator and then factor x to the 3rd power plus 1 using the formula for the sum of cubes, but that's going to be a lot of work using partial fractions. So instead, I'm going to use a trick that makes everything simplify very nicely. So here we have negative 3/2 times the integral of 1 over. Now for the denominator, I'm going to factor out x to the 4th power. So we get x to the negative 3rd plus 1. And you'll see if you distribute this, that we get the original expression back. And don't forget your dx. Now I'm going to bring this x to the 4th power from the denominator into the numerator by writing it as x to the negative 4th power. So we have negative 3/2 times the integral of x to the negative 4th power over x to the negative 3 plus 1 dx. Now we can make a substitution y equals x to the negative 3rd power plus 1. Then we see that dy equals negative 3x to the negative 4 dx. And we see that this is very nice because it's going to cancel out with our numerator here. So dx equals dy over negative 3 times x to the negative 4th power. So we have negative 3/2 times the integral of x to the negative 4th power over y times dy over negative 3 times x to the negative 4th power. These two terms cancel out, and we can also cancel the negative 3's here, which leaves us with 1/2 times the integral of 1 over y dy, which is 1/2 times the natural log of absolute value of y, plus I'm going to add a constant c2. But now recall that y is simply equal to x to the negative 3rd power plus 1. So we have this is equal to 1/2 times the natural log of absolute value x to the negative 3rd plus 1 plus c2. So now we are finally ready to finish up this integral. We have the original integral is equal to 1/2 times the absolute value of x to the 4th power plus x plus c1 plus 1/2 times the natural log of x to the negative 3rd power plus 1 plus c2. Now let's combine these constants by letting c equal to c1 plus c2. Now while we're at it, we can also combine these natural logs together using logarithm properties into 1/2 times natural log of absolute value of, now we have x to the 4th power plus x times x to the negative 3rd power plus 1 and then plus c. And we can distribute these terms into the inside and get 1/2 times natural log of absolute value of x plus x to the 4th power plus x to the negative 2nd power plus x plus c. Now if we combine like terms, then we get 1/2 times natural log of absolute value of x to the 4th power plus 2x plus x to the negative 2nd power plus c. Now this might not be immediately obvious, but this is actually a perfect square. If we write x to the 4th power of x squared squared and x to the negative 2nd power as x to the negative 1 squared, then we see that this middle term is in fact 2ab, where a is equal to x squared and b is equal to x to the negative 1. So now we get 1/2 times natural log, and now our inside term must always be greater than 0 since it is a perfect square, so we can simply write parentheses instead of the absolute value. And we have natural log of x squared plus x to the negative 1 squared plus c. If we bring this 1/2 to the inside, it cancels with a square, so our final answer will be natural log of x squared plus x to the negative 1 plus c, or if you want, natural log of x squared plus 1 over x plus c.
Thank you for making it all the way to the end of the video. If you enjoyed, please consider liking and subscribing. It greatly helps support the channel. As always, this was Tejas Avyaan, and thanks for watching.